Hi, we are going to discuss about central tendency. It is a statistical measure in which a single value represents an entire distribution or tendency of observations to cluster in the central part of data. We have 2 points here. Single value which is going to represent an entire distribution and it is also clustered in the central part of data. We can take the example of mean. Mean is just a single value which is going to represent an entire distribution as well as it is also clustered in the central part of data. There are two properties of central tendency. First one is it aims to provide accurate description of entire data. A single value is a typical representative of entire data. Here are some examples of central tendency. These are arithmetic mean or simple mean, the geometric mean, the harmonic mean, median, and mode. First three, arithmetic mean, geometric mean, and harmonic mean are mathematical in character and give an indication of the magnitude of observed values. Median indicates the middle position and the mode tells us about the most frequent value in the distribution of data set. Arithmetic mean or simple mean. It is a value which is obtained by dividing sum of observations by their numbers. Mean. Sum of all the observations divided by number of observations. There are two types of mean, population mean and sample mean. Population mean. If given observation represents the population, then the mean is termed as population mean. It is denoted by Greek sign mu. So, population mean is set of n observations x1, x2 up to xn. Mean is represented by, or population mean is represented by the formula mu is equal to x1 plus x2 plus up to plus xn divided by n. Mu is equal to sum of xi over n. Here I is equal to 1, 2, 3 up to n. This letter is termed as sigma and it represents summation. Sample mean. If the given set of observations represents sample, it is termed as sample mean. It is the mean of n observations x1, x2 up to xn. It is represented by placing a bar on x, so it is x bar. Here is the formula of sample mean. X bar is equal to x1 plus x2 plus up to xn divided by n. X bar is equal to sum of xi over n. I is equal to 1, 2, 3 up to n. Geometric mean. The positive nth root of n set of positive values is termed as geometric mean. It is represented by formula g is equal to n under the root x1 multiplied by x2 up to xn. Harmonic mean. Reciprocal of the arithmetic mean of the reciprocal of the values. Here we can see that in the formula 1 over x1 is actually the reciprocal of the values x1, x2 up to xn, and n 1 over x1 plus 1 over x2 plus 1 over xn divided by n is actually the reciprocal of entire arithmetic mean. So sum of n over 1 over xi is actually the formula of harmonic mean. Here x is not equal to 0. Median. It divides the ordered data set into two equal parts, one part comprising of observations greater than and the other part comprising of values smaller than it. Formula. For ungrouped data, median is represented by median is equal to n plus 1 divided by 2. For grouped data, median is equal to L plus h over f into n by 2 minus c. Here, L is lower class limit of median class, h is the size of median class, f is frequency, n is number of observations, c is cumulative frequency of previous class. Median class is the class which contains n by 2 values. Mode. Mode is the most frequently occurring value or observation in set of data. Mode is represented by formula L plus Fm minus F1 cross H divided by Fm minus F1 plus Fm minus F2. L is lower class limit of model class, Fm is the frequency of model class, F1 is frequency of class previous to model class, F2 is frequency of class which is next to the model class. H is size of model class, which is actually the difference between upper and lower class boundaries.